Another magical Friday night. I think I'll sit this one at home. Unusual.
To understand the hydrofoil, one must first understand fluids, specifically liquids, which comes from the Latin word to flow. Unlike solids, liquids do not resist surface deformation, so they're willingly flowing, as liquids do. And they're always looking to decrease their potential energy, so they'll always flow downwards in response to gravity. One property of liquids is pressure. So instead of talking about force, as we would with a solid, we talk about force per unit area, which is pressure, because the weight of a liquid is evenly distributed throughout its body. Pressure depends on no other variables besides depth and density of the liquid. Another property of liquid which we need to discuss is its buoyancy, which is defined by Pascal's principle, meaning that pressure exerted anywhere on a confined liquid is unchanged to all parts of the liquid, and it's perpendicular to the walls of the container which the liquid is in, and also to any objects which happen to be in a solid. The technical definition of buoyancy is the upward force of liquids against submerged objects, and it's defined by the formula W, or weight of the body after submersion, is equal to the volume of the solid, which is also equal to the volume of liquid that the solid displaces, minus that same volume times the density of the liquid. And if the density of the solid is less than the density of the liquid, then the solid will move upwards in the liquid and float. Another property of liquids is viscosity, or the internal friction of a liquid. And now for Bernoulli's principle, which states that the pressure of a liquid decreases as the velocity increases. They're inversely proportional. So if you consider a liquid flowing in a freer space, it's flowing slower, but it has greater pressure because pressure is force per unit area. Whereas if a liquid is flowing through a more restricted space, it's flowing faster, but it has less pressure because it has less, surface contact. Bernoulli's principle is defined by Bernoulli's equation, which states that the total pressure of a liquid is equal to its static pressure plus its dynamic pressure, which is defined by its density times the square of its velocity divided by 2. The last two formulas, which are essential to our understanding of the hydrofoil, are the lift formula and the drag formula. They're quite similar, except that lift is the force that is perpendicular to the oncoming flow, and drag is the force that is parallel to the oncoming flow. So lift is helping it, drag hurting it. The lift formula is the force of the lift is equal to 0.5, the coefficient of the lift, which is determined algebraically, times the density of the liquid, times the reference area, is the square of the velocity of the object moving through the fluid. Drag is a very similar formula, so the force of the drag is equal to 0.5 times the drag coefficient, which is also determined algebraically, times the density of the liquid that you're moving through, times preferably the same reference area, times the velocity squared of the thing moving through the water.
We're smashing mics in karaoke bars. You're running late with half your makeup on. This method acting might pay our bills, but soon enough there'll be a different role to fill. I love this feeling, but I hate this part. I wanted this to work so much, I drew up our plans on a chart. Cars are flipping, I'm in hot pursuit. My character's strong, but my head is loose. She hits like ecstasy, comes over The tarot card